All right. Hey, everyone. Let's jump right in. We're going depth today, really deep into the world of design and engineering.
Not just the flashy end products.
Right, exactly. Like behind the scenes stuff.
Yeah. Yeah, we've got a ton of sources for this one. Insider perspectives, cutting edge tech. It's going to be good.
I'm excited. I think whether someone's like prepping for a big meeting where they know 3D printing is going to be a hot topic
Or just someone who loves figuring out how things actually get made,
yeah,
you know?
this deep dive is for you.
It's kind of crazy how often we use things every day
Oh, yeah.
and have no clue how much work went into getting them to our hands.
Right. Like, think about it. A sleek new car.
Or a skyscraper that just seems to defy gravity, you know?
Yeah, we just kind of accept it. But behind every single design,
There's this massive web of decisions, needs, and people.
we rarely even hear about.
Totally hidden.
So that's our mission today.
Yeah.
To give you the knowledge, to not just be impressed by the final product, but
To get it. Like, really understand.
yeah, to understand the forces that shaped it.
Totally.
Like, picture yourself holding your smartphone.
It's not magic, right?
No, there's a reason it looks and feels that specific way.
Exactly. And understanding that starts with recognizing that design and engineering are not,
Solo gigs,
no way, more like a huge team sport.
where everyone's got their own goals.
But they got to score on the same field somehow.
Okay, love that analogy. So let's meet some players. First up, we've got civil engineers.
Ah, yes, the large-scale project masters.
Right. Bridges, highways, all the stuff that keeps our world moving.
What's fascinating is their whole focus is this balance between safety and efficiency. Like, our source mentions how when they're planning a highway, it's not just about smooth traffic flow, they're also factoring in things like seismic activity.
Whoa.
So you're designing a bridge in earthquake territory. That adds a whole other level of complexity.
Right, the stakes are high.
Absolutely.
Okay, but then you've got electrical engineers, and it's like zooming into this tiny microscopic world.
Oh yeah, completely different.
These are the wizards behind our smartphones, laptops, all things digital.
And their needs are all about miniaturization. Right?
Yeah, like packing tons of power into these tiny spaces.
Plus, you've got battery life, user interface. It's a whole different ballgame.
But just as important to how we live our lives.
Every single day.
So we've got engineers juggling all these technical needs,
Uh-huh.
but where do we, the end users, fit into this whole puzzle?
I mean, think about it. When you choose a product, what really matters?
Yeah, good point.
Is it just about the price tag?
Yeah.
Or are you thinking about things like how long it'll last, how it looks?
Maybe even if it was made ethically.
Right. All of these needs end up driving the design process.
So it's like voting with our wallets.
You could say that.
Our choices tell designers what matters to us, and that influences what they make next.
It's a whole ecosystem.
Whoa, I like that.
Yep.
But to actually make those decisions, you need to be able to see the big picture, right?
Totally. That's where visualization comes in.
Right. So we're talking blueprints, CAD software, that kind of thing.
Absolutely. Those are essential. But one thing that surprised me from this research was the role of physical models.
Really?
I know, right? In the age of virtual reality, who's still building scale models?
Here's old school.
But there's a reason. It's about bridging that gap between an abstract design and something you can,
See.
touch and feel. Our sources point out how these models aren't just for show either.
Like, they serve a real purpose.
Exactly. Take that example of redesigning an urban park. They actually built a scale model.
Wow.
And it wasn't just to make it look pretty.
Yeah, what's the point?
It helped everyone involved, the stakeholders, really see how people would actually use the park.
Oh, I get it.
Like things like how pedestrians would move through the space, sight lines, even where the best shade would be.
That's smart.
It's stuff you can't fully grasp from a flat drawing.
It's kind of like planning a room layout before you buy furniture, You don't just want to imagine it. You want to get a feel for the space.
Precisely. That's what those models do. They make the design come to life, but on a smaller scale.
Okay, but obviously not everything can be made into a physical model.
Right.
Especially with really complex designs,
Right.
you need to go digital. And that's where we get into the world of,
Virtual testing.
this is where it gets futuristic.
For sure. We're talking about using crazy powerful software to simulate real-world conditions.
Whoa, so like imagine virtually stress testing a bridge before you even build it.
Yes. Or fine-tuning the aerodynamics of a car to make it super fuel efficient. That's what tools like FEA and CFD let engineers do.
Okay, hold on. Gotta pause you there. FEA and CFD, those sound like something out of a sci-fi movie.
Uh-huh. They kind of are.
Yeah.
FEA stands for finite element analysis.
Okay.
Basically, it breaks down a complex design into these tiny virtual pieces,
Uh-huh.
and then it simulates how each one would react under stress. It's like a digital crash test, but for anything, bridges, airplanes, you name it.
So before they even start building the real thing, they can spot potential weak points. That's incredible.
It really is. Helps prevent disasters and saves a ton of time and money.
Wow. Okay, what about CFD?
So CFD stands for computational fluid dynamics.
Right.
And that one's all about how things move through air or water.
So less about how solid something is, more about how smoothly it flows.
Exactly. Super crucial for designing things like airplanes, cars, even wind turbines.
I see. By understanding how air flows over surfaces, they can tweak the shapes for better performance.
You got it.
Okay, so we've got these incredible tools that can basically simulate anything.
Pretty amazing.
But eventually, you got to actually tell the people building the thing what to do, right?
Right, you need instructions.
That's where file formats come in.
They're like the language of design, the way we translate these super complex ideas into instructions for actually making something.
So it's like a universal translator for the world of making stuff.
Kinda, but it's not always that straightforward. There are tons of different file formats, each with their own quirks and strengths.
Okay, so like different languages almost.
Yeah, you could say that. Even if you're not an engineer, there are a few essential ones to know about. If you're into 3D printing, STL is your best friend.
Ah, yeah, 3D printing is getting so popular now.
It's basically the standard for turning a digital 3D model into something a 3D printer can understand.
Okay, got it.
Then you've got DXF, which is all about 2D precision.
So like architectural blueprints, that kind of thing.
Exactly. Perfect for things like laser cutting, too.
Yeah.
It's the go-to when you need those lines and measurements to be super accurate.
So one's about 3D objects, the other's about super precise 2D plans.
Exactly.
What else is in this file format toolbox?
Well, there's VRML. This one's where things get really cool. It lets you create interactive 3D models. So it's not just a static image. You can actually move around inside it, explore it from different angles.
Whoa. So it's like stepping into a video game version of the design.
I love that. That's a great way to put it.
Very cool.
It's getting really big for things like architectural walkthroughs and product demos.
I bet. So we've covered so much already, from like basic needs to these futuristic simulations. But what about the people behind all this? There's got to be a ton of different roles and expertise within design and engineering, right?
Oh, absolutely. And they all need to work together like a well-oiled machine to take a design from that initial spark of an idea all the way to the final product.
Yeah.
We've talked about civil and electrical engineers,
Yeah.
but you also got mechanical engineers, software engineers, industrial designers,
It's like a whole orchestra, everyone playing different instruments but working together to create.
a symphony. And someone's got to conduct that orchestra.
Right.
That's where project managers come in.
Ah, of course.
They're the ones keeping everyone on track, making
Yeah.
sure deadlines are met, the budget's in check.
Sounds like a tough job.
It can be, for sure.
What about the people who actually build this stuff? The
Yeah.
manufacturers and fabricators.
They're absolutely crucial. They take those designs and turn them into physical reality.
Right.
And it's not just blindly following instructions either. They often bring their own expertise and experience, suggesting improvements or finding creative solutions to problems that come up during manufacturing.
So it's a back and forth.
Definitely. It's not just brain power, it's craftsmanship too.
I get it. And all of this, every single step, is ultimately driven by us, the users, and our needs.
Exactly. Whether it's a bridge that gets us safely across a river,
Or a phone that keeps us connected.
or even a chair that's actually comfortable to sit in.
It all starts with understanding what people need and want.
Oh, couldn't have said it better myself.
My mind is officially blown, and we're just getting started. When we come back, we'll dive even deeper into this world of file formats.
Exploring some of the more specialized ones.
Yeah, and how they're pushing the boundaries of what's possible in design and engineering. Stay tuned.
Welcome back, everyone. Ready to keep diving deeper?
You bet. Last time we were getting into file formats, those unsung heroes of design and engineering.
Right, we talk about how they're like the bridge between those cool digital designs and actually making stuff in the real world.
Exactly. STL for 3D printing, DXF for precise 2D plans.
And even got a little taste of that immersive VRML.
Yeah, that one was mind-blowing. But there are so many more out there, right?
Oh yeah, tons.
And I'm guessing they get pretty specific depending on what you're trying to build.
For sure. So let's unpack a couple more that are really key in that whole design to manufacturing pipeline.
Okay, hit me.
Like you've got DWG. This one's a major player in the world of CAD, computer-aided design.
Okay, so we're talking serious design software here.
Oh yeah, big time.
What makes DWG so special?
Well, it's all about capturing those really intricate details and making sure the measurements are super precise. Think about architectural plans for a massive skyscraper.
Okay, yeah.
Every single wall, window, pipe, it all has to be exactly where it needs to be. That's where DWG really shines.
So it's like the ultimate blueprint, but digital.
Precisely. And because it's so widely used,
Yeah.
it allows for really smooth compatibility between different CAD software.
Which is key for teams working together.
Absolutely. You don't want architects and engineers talking past each other, digitally speaking.
Right, totally. What other file formats are essential in this process?
Okay, so we've talked blueprints. Let's shift to something a little more visual.
Okay.
How about 3DS files? This format is all about making designs look insanely realistic.
Oh, wow.
Think about those super high-quality product renders you see online, or even the special effects in movies.
Yeah.
A lot of that starts with 3DS files.
So it's not just about the shape of an object, it's about making it look photorealistic with textures and lighting and all that.
You got it.
Yeah.
It's huge in industries like gaming, film, product design, anywhere. Visual appeal is just as important as how the thing actually works.
This is making me realize just how much I take for granted. Like, I see a cool ad for a new product, and I just assume it's a photograph.
Right.
I never knew there was all this digital artistry happening behind the scenes.
Oh, yeah. Tons of it. And it's not just about making things look pretty either. These 3D visualizations are super useful for communication, making sure clients and everyone involved really understands what the final product will be like.
Yeah, that makes sense. Okay, so we've got our designs visualized, tested out virtually, but at some point, those designs have to go from the computer screen to a physical object.
Right.
And that's where things get really hands-on.
Absolutely. Remember we were talking about digital testing techniques like FEA and CFD.
Yeah.
Those are great, but eventually you got to build the thing.
And bring it into the real world.
Exactly. And that's where knowing specific tools and techniques is crucial.
So it's like the difference between having a recipe for a cake and actually knowing how to use the oven and all the equipment.
Love that analogy.
Yeah.
You can have the best recipe, but if you don't know how to use the tools, that cake's going to be a disaster.
Aha. Yeah, for sure. Okay, so what are some of those essential tools and techniques that help bridge that gap?
Well, let's start with mechanical animation. And this isn't just about making cool-looking visuals. It's about really understanding how different parts move and interact.
Okay.
For example, imagine you're designing a robotic arm for a factory.
Lots of moving parts, precise movements.
Exactly. Mechanical animation lets engineers simulate how that arm would move, make sure it can do its job smoothly and efficiently.
Nice.
They can spot potential collisions, optimize the movements, basically give it a virtual test run before they build the real thing.
So it's like choreography, but for robots.
I like that. It's all about making sure they move gracefully and don't bump into each other.
Haha, very cool. What other skills are important in this whole digital to real world process?
Another big one is 3D model manipulation for CAM production. CAM stands for computer-aided manufacturing,
Okay.
which is basically using software to control those machines that build things like 3D printers or CNC milling machines.
Ah, so this is where the digital design actually gets turned into a physical object.
You got it. But here's the catch. You can't just take any 3D model from your design software and hit print.
It's not that simple.
Nope. The model often needs to be adjusted and optimized for the specific manufacturing process you're using.
Oh, interesting. So not a one-size-fits-all situation.
Exactly. For example, if you're 3D printing something, you might need to add support structures to the model to keep it from collapsing during printing. Or if you're using a CNC machine, you might need to simplify the model's geometry to make it easier for the machine to cut.
So there's this whole hidden language between the design world and the manufacturing world.
There really is. And speaking of language, one of the most important things in this translation process is communicating surface finish and datums.
Okay, hold on. Surface finish, I get. You want the final product to have the right texture, smoothness, all that. But what are datums?
Datums are basically reference points on the 3D model.
Okay.
They tell the manufacturing machines exactly where to start, where to measure from, how to make sure everything fits together perfectly.
Ah, so it's all about precision.
Precision is key, especially when you're making super precise components like parts for an airplane engine or medical device.
Right, the stakes are high.
Absolutely.
It's amazing how much detail goes into all this.
All right.
It's like a giant puzzle where every single piece has to fit together perfectly.
Exactly. And one more thing that's often overlooked but super important is gathering model information.
Like, what kind of information?
Things like the volume of the object, its
Mm.
center of mass, how much it weighs overall.
Okay.
Might seem basic, but it's crucial for knowing how the design will behave in the real world.
Give me an example.
Sure. Say you're designing a drone.
Okay.
The center of mass is super important for making sure it's stable and controllable during flight.
Right, so it doesn't just tip over or something.
Exactly.
Yeah.
If the center of mass is off, the drone might be wobbly or even impossible to fly.
Like trying to balance a seesaw.
Exactly. And knowing the volume and mass can affect things like what materials you use, manufacturing costs, even how you ship the final product.
This is blowing my mind. I never knew how much thought went into every little thing.
It's a lot. It's not just about making something that looks cool. It's about making something that works, that's safe, efficient, and that meets the needs of the user.
Yeah, it all comes back to the user.
Always. And remember, we've only scratched the surface of all the different roles and expertise involved.
Right.
There are so many more people who are crucial to bringing designs to life.
Like who? Give us a sneak peek at what's next.
Well, we've got manufacturing engineers, the masters of efficiency and quality control.
Okay.
Then you've got structural engineers making sure buildings and bridges can handle the forces of nature.
It takes a village.
It really does. And we can't forget all the skilled tradespeople who actually build these things with their hands and expertise.
So true. And we haven't even touched on the role of consultants and specialists who bring all kinds of unique knowledge.
Well, yeah, tons of them. Sustainability experts, material scientists, testing labs, all contributing to this giant web of collaboration.
Wow.
And it's all driven by that same goal, to create things that are functional, beautiful, and ultimately make our lives better.
I am loving this. We've got so much more to cover, so stick with us as we continue our deep dive into the fascinating world of design and engineering. All right, welcome back, everyone. We are in the home stretch now of our deep dive into the world of design and engineering.
We've covered so much ground already.
I know, right? It's mind-blowing. But one thing that really stuck with me from last time is that it's not just about technical skill.
No, it's so much more than that.
It's about teamwork and communication, like big time.
Absolutely. Design and engineering, they're deeply collaborative fields.
You've got all these different people, architects, engineers, manufacturers, all working together.
Towards the same goal.
Yeah.
And that requires clear communication every step of the way.
I can imagine things getting lost in translation pretty easily if everyone isn't on the same page, you know?
Oh, yeah, for sure. So how do they make sure everyone's speaking the same language? Well, it starts with really clear and concise documentation. Things like detailed drawings, specifications, those technical reports, you know.
So it's like a super detailed instruction manual for building something complex.
Yeah, exactly. But it's not just about words on a page either. Visual aids are super important. Things like 3D models, simulations, even those physical prototypes.
Like we talked about before.
Exactly. They can really help bridge that communication gap, make sure everyone's seeing and understanding the design in the same way.
Right. It's that whole a picture is worth 1,000 words thing.
Totally. But even with the best docs and visuals, you still need good old-fashioned human interaction.
Face to face.
Exactly. Regular meetings, site visits, even just casual conversations, they're so important for building relationships, tackling any concerns that pop up, and just making sure the whole team is vibing well.
It's like building a team spirit.
Exactly. And it's not just communication within the design and engineering teams either.
Right. It goes beyond that.
It's also about communicating effectively with the clients, the stakeholders, the public, you know.
Yeah, keeping everyone in the loop.
Especially with those big projects that have an impact on communities and the environment, got to keep everyone informed.
Makes total sense. And speaking of impact, that brings us to another super important aspect of design and engineering, thinking about the needs of the end users.
The people who are actually going to be using and interacting with what we create.
It's so easy to get caught up in all the technical stuff and forget about the human side of things.
So true. What are some of those key user needs that really drive the design process?
Well, first and foremost, it has to be usable, you know.
Makes sense.
A product, a building, whatever it is, it needs to be intuitive and easy to use.
Right. Nobody wants to feel like they need a PhD just to figure out how to use a simple coffee machine.
Exactly. And it's not just about ease of use. Accessibility is huge, too.
So that everyone can use it.
Exactly. Design should be inclusive, thinking about people of all ages, all abilities.
Yeah, that's so important. Everyone deserves to benefit from good design. What else matters to users?
Well, aesthetics play a big role, too. How it looks.
Yeah, People want things that look good, that are visually appealing, that enhance their surroundings.
For sure, I know I'm way more likely to use something if it's pleasing to the eye, like if it just looks nice.
Totally. And then there's durability and functionality. Those are key too.
So it lasts and it does what it's supposed to do.
People want things that are built to last, that work reliably.
Nobody wants a bridge that's going to fall apart or a phone that's constantly glitching.
Exactly. It's
Yeah.
about that balance between beautiful and practical.
I like that. Okay, what else?
Well, as we all become more aware of, climate change and our impact on the planet, sustainability is becoming a bigger and bigger need.
For sure.
Users are looking for things that are eco-friendly, that don't waste a lot of energy.
Designs that are good for the planet.
Exactly. It's about creating a better future for everyone.
Not just for us, but for, like, generations to come.
Exactly. And of course, we can't forget about safety and security. Those are always at the top of the list.
Of course, those are non-negotiables.
Whether it's a car with the latest safety features or a building designed to withstand earthquakes, people need to feel safe and secure.
Yeah, it's about designing with people's well-being in mind.
Couldn't have said better myself. And it's all about constantly evolving and adapting to meet those needs as technology keeps advancing and society's values change.
This whole journey has been so eye-opening. We've gone from the nitty-gritty details of engineering to the big picture impact of design on our world.
I know, it's been quite the deep dive.
It really has. I'm looking at everything around me differently now.
Me too.
Who knows, maybe this will even inspire some of our listeners to become the next generation of engineers and designers.
That would be amazing. The world always needs creative people who are passionate about making things better.
That's a great way to put it. Well, that's all the time we have for today's deep dive.
It flew by.
It really did. Thanks to everyone for joining us as we explored the fascinating world of design and engineering. Until next time, keep exploring, keep asking questions, and never stop learning.